Welcome to another video in this statistics using R series. Today we will be learning a very important topic in statistics, mostly used in biostatistics and business analysis as well. It's called hypothesis testing. I will break this video into two parts. In the first part today, we will learn what is hypothesis and how do we form our hypothesis, and then to test hypothesis using Z-score. In the next video, I will come with different tests for hypothesis like t-test, p-values, ANOVA, etc. So let's start with what is hypothesis. So what is hypothesis? It's a statistical technique to test some hypothesis about the population from which the sample is drawn. So as I have said in the last video, what is population and what is sample, and there are different methods of sampling. So if you are drawing some sample out of population, mainly to test some statistics, like I have given a statement like iPhone are costly. So this is a statement that you are likely to check by taking some iPhone out of the market, and then you can check whether this statement is right or wrong. But you have to have some ground statistical data before testing any statement. Like the first statement which I have given, that iPhone are costly, this is infeasible to test because I do not have any background data for that. Where I have background data for in the next statement, where I said that iPhone are costly given that we consider any price greater than 40k as costly. So you pick up 10 different iPhone models from the market and you test whether this statement is right or wrong, and then you have to test your hypothesis. Why? Because out of the 10 samples, that out of the 10 items in your sample, some may be greater than 40, some may be less than 40, but you cannot be I cannot surely say that this is the characteristics of the whole population. What I mean that the characteristics of the sample may or may not be in a same line with the characteristics of the population. So you have to establish whatever decision you have taken or whatever conclusion you are drawing from the sample, that your conclusion out of the sample is true for the population as well, or your hypothesis has to be justified with the population as well. So hypothesis actually concludes two things, that your sample selection is good, research conclusion you are trying to convey from your sample is actually true for the population as well. So how to form hypothesis? There are two kind of hypotheses that you need to define whenever you are trying to prove something or establish some result in out of your sample. That two hypotheses are: the first one, your null hypothesis, also known as H0 or H0. It is the hypothesis that is to be tested, and along with the null hypothesis, the other hypothesis that you need to define is the exact opposite in some sense of your null hypothesis, is called alternate hypothesis, or HA1. It is said denoted with HA or H1. And so it is the hypothesis that in some sense is contradictory to the null hypothesis that you have defined. And most often you are trying to reject the null hypothesis to establish something novel. Why? Because if you are trying to do something novel or trying to establish something novel, that means you are going against the norm of the current norm of the society or current norm of the science or statistics. So if you are with the norm of the society or science or statistics, then you do not have to establish yourself, do not have to prove yourself. If you are only against the current norm of the society, then you have to establish your result or your statement. So that statement is the alternative hypothesis. Something which is going along with the flow is called null hypothesis. Something that is already established or already norm of the society or science is known as null hypothesis. Here, so null hypothesis is accepted to be true. It is true until it's proven wrong. So if you are trying to reject the null hypothesis, then you have to test your statistics to prove the null hypothesis wrong. So it is like innocent until proven guilty. So you have to prove the null hypothesis wrong by giving some statistics. say mean blood sugar level of the people in India is say 80 milligram per deciliter. So this is a statement. How do I draw hypothesis out of this statement? The null hypothesis out of this statement will be the statement itself, that the mean is 80 milligram per deciliter. So what will be my alternate hypothesis? Exactly opposite to the null hypothesis. It will be like the mean is not 80 milligram per deciliter. So currently, if there are out of the population, it is established that the mean is 80 milligram, and out of some sample, suppose say some malnutrition population of some malnutrition area, you are trying to define that your sample mean is not 80 milligram per deciliter, then you have to establish this alternate hypothesis. Otherwise you have to accept the null hypothesis. How to accept or reject the null hypothesis? There are some well defined steps. You have to follow those steps, define or accept or reject the null hypothesis. So it starts with the steps like this. First step is to set up the hypothesis H0 and HA, that is your null hypothesis and alternate hypothesis. Given a statement or given a problem, you have to first identify what is your null hypothesis and what is your alternate hypothesis. After defining them, in step 2 we identify the test statistics and its probability distribution. Here I will take a normal distribution, but there are different distribution we will take in later videos. So after identifying the test statistics and distribution, we have to set up a suitable significant level. Now what is significant level? It is also denoted by alpha as well. Significant level says that how much significant your result is. Like for example, significant level can be like 5%. So 5% level of significance means that we are 95% confidence with our result. That is 5% of time we are taking wrong decision only. So here the confidence level, if the significance level is 5%, that means that the confidence level is means that confidence is equal to 100 minus alpha, that is 100 minus your significance level. So if 5% significance means 95% confidence. That 95% basically falls within this acceptance region. In this graph, it is a normal distribution has been taken of the statistics from your sample. Now this is the distribution of the sample generally. So this region calls the acceptance region. Acceptance regions means acceptance of the null hypothesis, confidence on your null hypothesis. So if your significance level is 5%, then means 5% of time you are rejecting the null hypothesis. So here, if I go back to the previous slide where I said the mean blood sugar level of Indian population is 80 milligram, that is your mean. So maximum chance of an Indian person of having a blood sugar level is 80 milligram. So here we go, that this is your 80 milligram, or mean will fall here. So if it is converted into a standard normal distribution, that 80 will convert it to a 0 by the formula x minus mu by sigma, where sigma is the standard deviation. So you have to convert that normal distribution into a standard normal distribution, but here the mean is always your 80. Now if you are to accept the null hypothesis, that is 80 milligram per deciliter, you have to, your sample mean has to fall within this region. If your sample statistics that is falling way beyond the mean of 80 milligram, then only you can reject. So I accept the statement of null hypothesis 95% of time, and 5% of time I reject. Now a statement like that mean blood pressure is, mean blood sugar level is 80 milligram, it can go wrong in two ways. Either I find a mean which is greater than 80, or I can find a mean which is less than 80. The statement becomes false in both the occasion. So it is called, it is having a two-sided tail. This kind of testing is called two-tailed hypothesis testing, where you can reject your null hypothesis at both sides of the mean. Here with a possibility of alpha by 2, a significance of alpha by 2. Here also at the right hand side a significance of alpha by 2.
Now, what is one-tailed hypothesis testing? If the example that we had taken, like, so we can bowl at 140 kilometer per hour. If he bowls something greater than 140, it is good. If he bowl less than 140 only, then it is, his statement is going to be false. We reject the hypothesis only at the left hand side. This is called a left-tailed hypothesis. Like if I say mu is greater than equal to 23, so any value of mu greater than 23, like 24, 28, 30, 120, any value will be accepted. But if I have any value of mu less than 23, will be rejected. So it is called a left-tailed hypothesis. Whereas if I say mu is less or is equal to 23 is my hypothesis, then any value which is greater than 23 will reject the null hypothesis. So it is called a right-tailed hypothesis. Now the next part that we need is the critical part, this critical zone of Z. Here remember, I have already written some value of Z. How do I get this value? I have to find out. So critical Z value. Z value, it is a standardized code that describes how many standard deviations an element is from the given mean. You have a mean at 0 as a standard normal distribution, and at the right and left hand side you are going to have some standard deviation. You are deviating from the mean with some standard deviation. Now how many standard deviation you are away from the mean is measured by the Z value. Now you have a critical value, critical region, or you have a threshold value beyond which you can reject your null hypothesis. That critical zone is set up by your level of significance. So you are rejecting or accepting your null hypothesis on the basis of that Z value. That Z value is nothing but the level of standard deviation you are getting away from your mean.
The level of significance here for two-tailed test at 10% is 1.65, 5% 1.96, 1% is 2.58, 0.1 is 3.29, and in case of one-tailed test it is like 10% 1.28, at 5% is 1.6, at 1% 2.3, and 0.1% is 3.10. You will get the complete table of Z value in internet and from various web sources, but I have noted this for 8 down because in most of the competitive exam you are asked these on these four values of critical level only, that is at 10, 5, 1 and 0.1%. And you also should note it down that confidence level is 100 minus significance level. So you may be asked question on by given the significance level which is noted here, or also you can be given like confidence level, that is on 10% significance means 90% confidence.
The procedure for hypothesis testing, we had stopped at step 2. Remember here, step 3 we had set up a suitable significant level alpha. Now selection of appropriate probability distribution for the test, I had said it earlier, identify the test statistics. So here we select a appropriate probability distribution in step 3. Now like it can be t test, it can be f test. Most often we use Z score. How do we calculate Z score? This is the method of calculating Z score. Z is equal to x bar minus mu. X bar is your mean of sample. What is mu? Mu is the mean of your population. The population is the total set of data points or elements, and sample is the subset of the population that you have selected through some sampling methods. So x bar is the mean of sample and mu is the mean of population, and sigma is standard deviation of sample. N is the, or say, size of sample. So these are the 4 things that you record. You make the decision depending upon your Z score that whether to accept or reject the null hypothesis. Now before taking the example, what kind of error you can have while making a decision? Now, if the truth value of your statement is H0 and HA, and your decision is like accept H0 and reject HA, four kind of situation you may round up to. You may either accept the null hypothesis or you can reject the null hypothesis. If you accept the null hypothesis, and if it is true that the if the null hypothesis is true, then you are in this box, first box. And if you accept the null hypothesis, but actually the truth is that the null hypothesis is wrong, that is the alternate hypothesis is true, you will have in this box. And if the null hypothesis is true but somehow you have missed it and you have rejected the null hypothesis, then you will be in the third box. Whereas if the null hypothesis is false, that is you have rejected the null hypothesis and it is true that the alternate hypothesis is correct, that is null hypothesis is false, then you are in the fourth box. So what are the error boxes? You can easily assume the third and the second box are the error boxes. Now the third box, where you reject the null hypothesis where the null hypothesis is true, is known as type 1 error, and the second box, where you accept the null hypothesis where the alternate hypothesis is true, is known as the type 2 error. Now here we will take a problem. The example says that a random sample of 50 items give the mean 6.2. Now we can relate to your example that we had taken earlier of that mean blood sugar level of India. That a random sample of 50 items give the mean 6.2. So you have selected a sample, and from that sample you can easily calculate or estimate. Now that mean that you find it's 6.2. And the variance, now you also can find the variance from your sample, that is 10.24. Can it be regarded as drawn from normal population with mean 5.4 at 5% significance? You also know that the normal population have a mean of 5.4, that is the total population has a mean of 5.4, it is said. And you have to test whether that the normal population have a mean of 5.4 or not. You have a sample with mean of 6.2 and you have to test whether the normal population is having a mean of 5.2 or not.
These are the values that I got from the example, that the number of items in the sample n is equal to 50 and the mean of the sample is 6.2 S bar, and sigma, the standard deviation, is square root of the variance given in the sample, which is 10.24 is 3.2. So in the step 1 I will define my hypothesis, that is my null hypothesis and my alternate hypothesis. So here is my null hypothesis, which is H0 is that mu is 5.4. Mu is the population mean. Mu is the population mean. And obviously the alternate hypothesis then will be exactly opposite to this, that is that mu is not is equal to 5.4. Now what our target is, that we want to reject H0, that is we want to accept the alternate hypothesis, that is our target. So in step 2, my step 2 is to define the test statistics. So test statistics here is Z. The formula for calculating Z is x bar minus mu by sigma by square root of n. So if I put the values here, is 6.2 x bar minus 5.4, my population mean, by sigma will be square root of 10.24, that is 3.2 minus by root over of n, that is 50. If you calculate this value, it will be 1.77. So this is for my step 2. So my observed value of Z is, this is my observed value of Z. Observed Z value is equal to 1.77. Now what is my step 3? In step 3, I have the level of significance given in the example is alpha is equal to 5%. That means it is equivalent to 0.05. This is my level of significance. So from the table that we have seen, we can find out the critical value. So the critical value is equal to 1.96. Critical value is Z is equal to 1.96. That is the critical value of Z. That what does that mean? That means if this is my normal distribution of the sample, so here is the mean 0, then in this region I accept the null hypothesis, which is 95% of confidence. So in this 95% region I accept my null hypothesis, and here I'll reject my null hypothesis with a cutoff value of 1.96. This is Z is equal to 1.96, and this is Z is equal to minus 1.96. So what I do here, my alpha is 2.5% and here my alpha is 2.5%. So this is the region for alternate hypothesis, whereas this is the region for my null hypothesis. This is what I do in step 4. So my final step is taking the decision. Step 5. Is decision that I need to take is that test or observed Z score is less than actual or say cutoff Z score. That is why? Because obviously 1.77 that I got is less than 1.96. So what I'll do that we have to accept the null hypothesis, because 1.77 is in this region, not in this region. So we have to accept the null hypothesis. So my decision is that I accept H0. This is the decision I take. So my conclusion that I can draw from this example is that mu is equal to 5.4, that the population mean is equal to 5.4.
So thanks for watching the video. If you like it, you can subscribe my channel and share it.